This is the final installment of my build of the golf putter, and just shows some of the issues I had and some of the minor things that I did to overcome them. They may be of interest. I've modified a few parts, and you can find my modifications on printables.com if you want to use them. The very first thing I did was try to test the lift mechanism, and I didn't have a 16 millimeter M2 rod, so I just used an M2 screw, a 12 millimeter one. If you countersink it in, that's fine. Sand this well so it goes up and down, and then you can test your unit to make sure it goes up and down fine. And you can install the actual unit. Don't worry that goes up a little too much, because in the final code that will be taken care of. Now this all uses some test code that I put into my version of the software, and I'll just show you what I did here. The software that comes with the project has all these defined statements which give the initialization and the maximum values that you can tweak if they don't seem to work quite as well for you as they need to. And you'll notice at the very beginning there's one variable called Servo home. When it's in the 1 position, it will just stay in an alignment loop. That means it'll just put all the servos sort of to their initialization position. But what I did was, when it's in that mode, I added code here in this loop that set all the servos to their maximum value, and I waited 3 seconds, and I also turned on a light so I could tell by the light whether the servo was at the maximum or minimum. And then after 3 seconds I put it in the minimum, turned off the LED, and that allowed me just to test my servos. So when that variable is a 1, I'm in this test mode. You may want to add something like that into the code. So that was the ball lift. The next thing is to make the TPU axles, or that's what I did. These need to be flexible. Don't shy away from TPU. TPU is pretty easy to print. If you can print PLA and PETG, you can print TPU. You can get 1/2 kilogram of it for not too much money. And these were just some of my settings from Prusa Slicer. It may give you, if you haven't printed with TPU, it'll give you something to go by. You'll notice that it's got a fairly small footprint, but you don't want to use a brim or raft. They're hard to get off TPU. You want to make sure that your filament's dry. I have a filament dryer. I usually dry my filament for at least an hour, and I keep it wrapped so not too much moisture gets in it. 0.2 millimeter layer height. You can use 2 walls, 2 perimeters, 2 top and bottom. You probably could get away with 1. You don't want it to be too thick and not that flexible, because it will pull up on the splines. I would recommend, no matter what surface you're using, whether it's a smooth surface or a textured one, use glue stick. It just makes it stick a little better, and it gives you that buffer that won't hurt smooth surfaces. I use 220 as my nozzle temperature. For my first layer bed I used 70, others were 65. And my speed settings, you got to print it a little slower. These were just the speed settings from Prusa Slicer I used, and they may be of value. So my axles worked pretty well first time. I did have problems with the splines, and here's why. The recommended servo is a Smraza SG90S, also called an S51. But you'll notice that this is not a very aggressive outline, and it's This is the servo spline or horn. It's hard to grab onto, but you'll notice it's also a 21 tooth spline, but the STLs are 25 teeth, so they're not going to match exact. And that can be a little bit, I found that was a problem I had. And I'll show you that in this little video here. I take the spline that came with the project. Now you can use Metal Gear servos as well. I had a Metal Gear servo before I'd ordered my Servo ones. And you'll see this slips, even on the Metal Gear servo. So I didn't get a good fit. So what I did was, this is one part I modified. And I'll show the modified part here. That part with the teeth, I made it smaller and solid. So it's just round. There's no teeth imprints in there. And what I did was use heat to melt that and force it over the servo. And this works better with a Metal Gear servo. I melted it over to form to the servo horn. Now what I used was a little blowtorch lighter that I got for $3 from a dollar store. Now you have to do it longer and slower. This is just showing, this is already a preformed one, but that will fit over there fairly well. Now I recommend you print out about, if you use my mod, print out about 4 or 5 of these, because it's going to take you a few times to get this just right. Now, I will say that this worked well for the Metal Gear servos. I'd almost, if I were doing this again, I'd use Metal Gear servos for the ones that interface to the 2 TPU axles. When I switched this back to the plastic gear Servo servos, I found they would slip after a while. They worked fine for a bit. After 2 or 3 days of use, they slipped. So I ended up gluing them very carefully at the bottom to the servo horn, because it was a plastic servo horn. It glued pretty well, but you're generally not going to get it off. I think that if I'd used the Metal Gear, that heat melt technique would be fine. If your TPU rod is too stiff, this is going to bend, and when it bends, if it's too stiff, it may provide a little force upwards and may tend to lift this servo up a bit. And one of the issues here is you haven't, there's no mechanism in here to screw this spline down onto the horn. That's why another suggestion might be to use some of the servo horns that come with the actual servo. You could cut them off and screw them down, and then you could maybe make an adaptive piece here that would go on and attach onto that servo horn. That's just another possibility. So that's what I did to make that work. I wanted to show this. This is the screws that you're going to use. These are, I think, a standard 8mm thread, and the screws are great. But you need a 4.5mm hex wrench, and if you've just got a cheap hex wrench with a few, 4.5 is not a standard size. And you're going to need an 8mm tap, because when you put that in, it's only going to go so far, and the threads are going to bind. So all the threads are designed to really use a tap, and you've got to be careful here. You don't want to cross thread it. If you ruin a thread in there, you're going to need to print another base. So as you get some resistance, just gently go back and forth, and eventually you'll clean out and create a nice thread in there. And so you just want to go back and forth very carefully, making sure you don't cross thread anything. And then if you do it fine, you should test all of these. You should find that your screw will go in very well. So make sure you have 8mm tap on hand. I'll go over now creating the junior robot part. I guess I had some issues with this, and some things I did different. One thing is you'll notice that there's an EMF that comes with the putter and with the flag that works in Cure, but I don't use Cure as a slicer, so I extracted the STL and broke it into two parts. And you can see, because I wanted to print these with different colors, I broke the flag into a separate part that I could print by layer heights to get the black 19 and the white base. And I attached them together with just some M2, I think 6mm long screws. But I've included those mods in my distribution, and there is two versions of the post. One, you can just screw the flag in. If you don't want to, you can just glue it in instead of screwing it in. Now, I found that the distance here for this rod was about 75mm as opposed to 79, which was recommended in the instructions. And I also modified this little piece here to make it a little deeper. And I used the same heat mod on this. I sort of filled it in and then I heated it up to form it on a little better. And I did all that while this was not installed in here. So that shows the two servos that are mounted there. I had a little issue printing this base. You'll notice that the layer lines are straight across here and they're really easy to break off. As you can see, I've done here. In fact, I did that twice. So what I did, and you don't need supports if you print it that way, straight up. However, those little tabs are pretty weak. I ended up printing this down this way, and now it's much, much stronger. Now you do need to add some support. And so I painted on support. This is the underneath of that piece, and this is that piece with the support. Now you're only adding maybe 1 gram of filament, so it's not that much filament. But it came out really well. The underside isn't quite perfect, but you don't see the underside. So that worked very well. Made it much stronger. Now this is the arm part that holds the flag, and you want this to be right out, right at the side here at this angle. So I just marked sort of the top of that so I knew the orientation of the arm. And then I modified this part. You'll notice it has a hole in it. I modified that part so I could put in an M3, I think 6mm screw with a washer, as opposed to gluing it, because I thought maybe I might need to take that off if things didn't work out. And sometimes you need to take it off if your length of your wire is not just right. You're going to need to take that off, make a shorter or longer wire. These are the 5mm bolts. So now to install this, used a little bit different technique. I put the legs in first and I moved that servo horn up a little bit, and you should be able to then attach that wire in. With some fiddling, obviously. But it will go. And there you see it installed. Now, we're going to do a little test just to make sure that things work. And really all I'm doing here is just making sure that goes up and down. The head just sort of sits in. And you can feel that spline there. and that will allow you to test both the servos inside the small little robot. My final test was for the larger robot. I'll just show what I did here. One of the things you'll notice right here is I put in a connector for VCC and ground. That comes out to that 5.5 millimeter plug that I used in the back. I mentioned that in part 1 video. So this is what my inside looked like. You have to make sure these are right down flush. And on the back you can see the 5.5 millimeter jack that I used to power it up. So this is now testing, it's bending properly. This is the shoulder turn. You can see a little bit of the motor turning the head. The head only turns a little bit. And we're testing the ball as well. So that was my final test. Everything seems to work. I basically from there just put the rest of the parts in. I did some modifications of code, but to modify my code I unplugged the back. I'll plug in and power the code, make the changes to the code, and once they're downloaded or uploaded to the Arduino board, I would unplug that and plug it back in and make sure everything works.